I'm gonna calculate the real speed.
Ever seen a girl throw 100 miles per hour?
People saying it's not 100 miles per hour, but have no way of proving it.
Yes, I can. I first found the location where you recorded this video. I don't want to say where it is, so I'm just gonna show this house in the background with the bushes in front of it. And this red tree right here. When you lob the ball to your wife, the horizontal position formula was initial velocity times the cosine of the angle you threw the ball times time. The vertical position formula was the same with the sine of the angle minus 0.5 times gravity times t squared. If you put y equals to 0, we can calculate your initial velocity to be gt divided by 2 times the sine of theta. I looked up the metadata of the video recorded and it was 30 frames per second. Then I counted a total of 77 frames where your toss was in the air, which is about 2.57 seconds. I also estimated the angle you threw the ball based on other objects in the video to be about 60 degrees. This means by doing some simple math, we can solve for the distance between you and your wife by plugging in initial velocity. It's gt squared divided by 2 times the cotangent of theta, or 18.6 meters. I'm being generous. I triangulated it based on your location and it was less than that. Now in your wife's case, I couldn't quite see her throw angle, so let's get rid of it. With the same formulas we solve for cosine and sine, and then use trigonometry, sine squared plus cosine squared equals 1 to solve for her throw's initial velocity, which is this formula. Her throw was 21 frames, which is 0.7 seconds. Which means we can calculate her throw's initial velocity to be 26.8 meters per second, or 60 miles per hour. You all love to comment about me for getting air resistance when it doesn't matter, so let's calculate it. We can model quadratic drag, which turns the motion into a system of nonlinear ODEs. K is drag coefficient times area, air density, which I calculated from their location, divided by 2 times the mass of the ball. We then solved this using Python. With air resistance, her throw speed was 61 miles per hour, which I think is very impressive, but let's be real, it's not 100.